find the vertical asymptotes and the removable discontinuities of the graph of f of x, which is right over here. And remember, the vertical asymptotes and removable discontinuities happen in places that aren't in the domain. So in order to do this, we're going to have to figure out what the domain of this function is. And since this is a rational function, it has a polynomial over another polynomial. That means that the domain is all real numbers except for the real numbers which make the denominator function 0. So we have to first figure that out. We have to find what the domain is. Oops. Domain. So that is the bottom function there. Not equal to 0. So in order to figure this out, what we want to do is we want to factor this polynomial here. And this is thankfully a good polynomial, an easy polynomial to factor, because each of the terms in the polynomial have an x. So we can just factor out that x first. So we factor out an x, we're left with x squared here, minus 6x here, plus 5. And we know that is not equal to 0. And so this is a good thing here because we have multiplication here and it can't be equal to 0. So that means that neither of these two factors here can be equal to 0. So therefore, we already know that x is not equal to 0. Or this thing in parentheses here is not equal to 0. X squared minus 6x plus 5 is not equal to 0. So this is good right here because we've already found one number that is not part of the domain, that being 0. For this one right here, this polynomial here, what we got to do is we got to find the 1, 2, or maybe even 0 zeros, real numbers that make this quadratic function 0. So we can do that either by factoring or we can do it with the quadratic equation. And I think factoring is probably the easier method to do, but if you want to use a quadratic equation, I don't really blame you very much. So remember, to factor, what we have to do is we have to find two numbers that multiply to 5 and add to 6, right? We want them to multiply to the constant term here, 5. We want them to add to the linear term, negative 6. Let me erase that and fix that. We want to add to negative 6. Let me make this 5 a little bit better too. Okay, so there are two numbers that multiply to 5 and add to negative 6, namely, yeah, there are two numbers that multiply to 5 and add to negative 6, excuse me, which are negative 5 and negative 1. Negative 5 times negative 1 is 5, and negative 5 plus negative 1 is negative 6. Okay, so that means that this polynomial here, it factors, I'm going to go down here, to x minus 5 times x minus 1. And we want this to not be equal to 0. So we know that for this to not be equal to 0, that means that x minus 5 is not equal to 0, or x minus 1 is not equal to 0. Those two here, and we can solve both of these inequalities. For this one, just add 5 to both sides, and we'll get that x is not equal to 5. For this one, just add 1 to both sides, and we'll get that x is not equal to 1. So now we know the domain of this function. So the domain is x is not equal to 0, x is not equal to 5, and x is not equal to 1. So we have those 3 points that are on the domain, and the question is whether they are wholes or asymptotes. Now, algebraically, there is a way to do this, and the way to do this is to also factor the numerator. And the numerator factoring is pretty easy. It factors as follows. Here, let me see. F of x is equal to, I'm just going to rewrite it, x squared minus 25 over the denominator was x cubed minus 6x squared plus 5x. And we already know what the denominator factors into. That factors into x times x minus 5 times x minus 1. And the numerator is a difference of two squares, and hopefully you remember from high school. If not, I'll show you over here as sort of a note. A squared minus b squared, that always factors into a minus b times a plus b. And you can multiply these out to check and make sure that's true. But the point is that this up here, this numerator factors into x minus 5 and x plus 5. And I know this because this first term here, this x squared term, this x squared, so that's going to be my a. And this 25 here, that's 5 squared, so that's going to be my b, and this is how it factors. And let's look at this. Let's look at this for a second, right? So we have a couple of terms here. We have this term here, right here, and that term there, right there. They're both x minus 5s. So if we could divide by them, they would cancel out. And we can divide for them as long as x is not equal to 5. Right, so here, so I'm just going to divide here, already keeping in mind that we know that x cannot be equal to 5. The reason we can't divide by it when x is equal to 5 is because then we're dividing by 0 in the denominator. That's no good. All right, so this is going to be equal to, what I have left over is x plus 5 in the numerator, and then in the denominator I have x times x minus 1. So you see how the x minus 5s, they've been removed. That is the way that we know that this one right here, this value that corresponds to the ones we removed, there are no more x minus 5s here. That is a whole or removable discontinuity. So x equals 5 is a whole. Now, there's no other cancellation that could go on here because I have an x plus 5 in the numerator, but I don't have one in the denominator to cancel. I can't cancel out my x's because the x, division doesn't undo addition. I can't cancel out the x minus 1 because there's no x minus 1 terms here. So that means these other two values here, this x, which corresponds to this value here, and this x minus 1, which corresponds to this value here, these are asymptotes. They're asymptotes because we can't remove the discontinuities. We can't get them to cancel out. So x equals 0 is, let's see, an asymptote. And also x equals 1 is an asymptote. So that's what you have to do. In order to figure out algebraically anyways, whether you have wholes or asymptotes, what you have to do is you have to factor your numerator, factor your denominator, see what you can remove. If you can remove something completely from the denominator, like our x minus 5s are now gone, that means it's a whole. We've removed it as a removable discontinuity. The things you cannot cancel out anymore that are still there in the bottom, those are asymptotes. And I will end this video now, and then in the next video, we'll talk about how to do this graphingly.